let's think about and classify some types of data that we collect in order to make better decisions and more informed decisions instead of going off our gut, which, by the way, also takes into consideration all of the data you've collected without explicitly doing it, writing it. Example 5, personal. List some kinds of facts or data that ECC keeps on every student. Okay, I actually want you to list some down for yourself. Some of the ones that come to mind for me is obviously we keep track of your name. We probably track your age. I know that we talk about the median age and being relatable and how we can serve students the best. We definitely keep track of your grades. We track your GPA. We track the number of credit hours that you are taking. We probably have your address on record because we have to know if you're in district versus out of district. So we probably keep that. I don't know. What else do we keep? Let's see. We probably know how much money you owe the college at a given point in time, or maybe you overpaid and the college owes you. So certainly anything financial stuff. Okay, billing. What else do we? Oh, I'm sure that you actually, in addition to grades and GPA, you might have taken like a placement test. You might have taken other stuff, and we have some of that data. I don't know. We track some data. We want to take care of you. So list some kinds of data that ECC keeps on every student. I mean, the list goes on. Yeah. As a matter of fact, these are all like ECC level for students, but I myself, I compare semesters. Like, okay, I wrote this test. How did students do on that particular topic? And sometimes I even drill down to each problem, like, oh, students are really good at that, but not so good at this. I better teach on that. And I also think, okay, did I write let's look at the actual test questions and if they were harder or not and how students performed. If I change the question to this, will they rise to the occasion, or will they kind of like show me that, nope, that didn't do it for me? So, I mean, and that's just me, one representative of a faculty member at ECC. So we actually do a lot of data-driven decision making in terms of keeping data. Why does our school, and that's not even to mention the fact that every student that I ever come across, I want to make sure that I do a pretty good evidence-based evaluation on what content you actually felt very confident in and you were great at, and what you needed to work on, and where your letter grade comes from. Anyway, why does our school keep this data? Well, I think to take care of you, if you want me to be honest, in our community. So we need to make sure that we are being fair. We need to make sure that that we are teaching you what the community needs, and we need to make sure we are serving the community's needs. So I would say, why does our school keep this data? I don't know. To make good decisions. At the end of the day, just to be good. Separate the data into two categories. Numerical measures versus non-measure information. Got it. Okay, so let's see. Numerical. GPA. That is this. Name, non-numerical. Age, numerical. That's time. Grades. So even though your GPA is a measurement that is created from your grades, the grades are actually just raw data. They're non-measure. They're just A, B, C's, and D's. But then we turn it into a measurement called the grade point average. So the average of your grades. Credit hours, that is a measurement of time. Your address, I would say that that's a non-measure. So even though your zip code, your area code, those are numerical things, that is actually a non-measurement because it doesn't measure anything. It tells us where you are, but not a measurement. Financial stuff, those seem pretty numerical measure. Okay, so we can separate these into two categories, numerical measures and non-measurements. And that brings me to this difference in data, qualitative versus quantitative. Qualitative gets its name because it's qualities, and quantitative gets its name because it's quantities or amounts. So, qualitative allows for a classification of individuals based on an attribute or characteristic. So, allows for classification I'll put my of individuals at the end. Based on some attribute. In other words, or i.e. characteristic, where it actually gets its name from, quality, okay, of individuals. Okay, so allows for classification based on some attribute, characteristic, quality of individuals. And now I use this word individuals. It doesn't necessarily have to be a person. An individual could mean, we could test batteries at a factory and say, are they good or are they bad? Are they defective or are they not defective? And I would call those characteristics or quality, and the individual would be each individual battery that we test. So I use this word individuals kind of more openly, not to mean a person, but just an individual thing or person or place. Individual noun, I suppose. Anyway, moving on. If you want to get into that, go into English. Quantitative data. This, to me, provides a numerical measure of something about an individual. So, provides a numerical measurement of something about an individual. Okay, and now we could classify based on this too. Like we could break people by age and say, okay, you're under 18, you're above 18, which we do a lot, and you're under 21 or you're above 21, which we also do a lot. we could still do a classification, but that wouldn't necessarily be an attribute or quality of an individual. It would be more specifically a numerical measurement of something about an individual. So these are purely qualities, and these are purely measurements. So the difference is these you can measure, these you can't really measure. You can't really measure brown hair. I mean, you would have to find some kind of quantifier for that. But you can definitely classify someone as a brunette or not. And so this would be just a sheer count of brunettes with that, so people with that quality. But this would be a numerical measurement. For instance, we could measure somebody's height. So people's heights. And then, I mean, the classification would be more vague, like tall and short. And we would just have a tally or a count of those who were tall and those who were short. And in my kids' case, they would, of course, say, well, I'm medium, because they don't want to be called little. But this is an actual measurement. So the distinction is that this is a quantity, this is a quality. Okay, let's work on that. Let's classify a bit. Consider each research question. Determine if the response to that will be qualitative or quantitative in nature. What math class did you take your senior year? Oh, that's a quality. Because immediately the response to that is going to be a title of a name, like it's going to be a class name. And that'll provide a classification, but is not a measure. How many credits are you taking this semester? That is a measurement of time. Quant. Okay, because I'm lazy, I'm going to shorten these to qual for qualities or qualitative, and quant for quantities or quantitative. So this is a measurement of time. How long do you work at your job each week? The response to that would be a measurement of time again. What is your zip code? The response to that will be a number, but it's actually a quality. It's a classification based on where you live. It's not a measure. So this, even though it's a number, it's quality. Duragizer is a battery company. They make car batteries. They want to know the average lifetime of their battery for advertising purposes. First, can they test all of their batteries to get this information? And I would say no. Once you drain a battery to find out how long it will last, it is dead and you throw it away. If you do that to all of the batteries at your company, you have nothing left to sell. So, can they test all of their batteries? No. Just test a few, which is called taking a sample. Is the data they are gathering qualitative or quantitative? And how can you tell? Well, here's what they're doing. They're keeping track of how long each battery lasts, and that is actually a numerical measurement of time. So this is quantitative. How can you tell? Because they are measuring the time it takes until each battery dies. ECC wants to know what percentage of their students on campus are here for their very first semester. Oh yeah, you know what we also keep track of? If you're like first generation, and there's all kinds of sorts of supports in place for that. So if you're first gen, like you should ask like, hey, you mentioned something about ECC caring about that. What'd you mean? I'm like, I'll tell you. Here for their very first semester. Rookies to our game. Can they get this information for every one of their students? Yes, absolutely. Every student who walks onto campus, who becomes a student. So as soon as you become a student, they have gathered that information on you. They make you fill out this thing, you tell them what's up, And can they get that for every single student? Yeah, because every single student has to go through orientation in order to register for class. So, yes. They don't have to take just do a few. They can get that information for every single student. Is the data they are gathering qualitative or quantitative? Okay, are you here for the first time? That is not a measurement. So because that's not a measurement, that's a yes/no response. That is a qualitative situation. How can you tell? Yes, no response is not a measure. Okay, so right off the bat, I know it's not a quantitative situation because it's not a measure. And it's really just a quality of, your experience. Let's take a peek at this one. The Lighten Your Eyes company wants to see how many of their light bulbs are defective. Currently, the company makes 50,000 light bulbs a day. Okay, got it. Can the company test all of their light bulbs in order to get this information? Yeah, but they probably won't. So, yeah, they could plug in. So imagine a factory and a production line, and you're making a bunch of light bulbs. You could have a worker plug in every single light bulb to make sure that it turns on and shines. However, you probably won't. And what are you going to leave it on until it sparks? I don't know, or fizzles out. So yeah, but will they? No. So this word can is a little bit tricky here. Can they test? Yes, but won't. Okay. They're likely to take a sample, but nonetheless. Is the data they are gathering qualitative or quantitative? How can you tell? Okay, well, the response. How many of your light bulbs are defective? The response is so the response is a number, but it's actually a count of a quality. So let me explain. If you are on an assembly line and you are asked as a worker to plug in a light bulb to see if it actually works, right? To see if it's a defective light bulb or if it's effective, so to speak. You plug it in and you say, did it light up? Yes. Did it not light up? Yes. Okay. So you are actually answering, is it defective? So the actual question here is it defective? And the answer to that, again, is a yes, no answer. Instead of answer, let's call it response. And that's a quality. So either it's defective or it isn't. And that's a quality of that light bulb. It's not a measurement. So a measurement would be how bright is it? We're going to measure that brightness using a number. How long did it last? We're going to plug it in and see just how many hours does a light bulb last. And that's a numerical measure of time. So is it defective? That has a yes-no response. And to me, that is a quality. It is not a measure. Yes and no is not a measurement. So how can you tell? Response is not a measure. Okay. So as an overall summary to this entire section, it was pretty rich. It had a lot of stuff in it. We were organizing data, okay? We started with some raw data, kind of had to think about what kind of data that was, and we started doing things like computing percentages, fractions, decimals, and degrees. We created some frequency tables and some relative frequency tables, so raw count of how many versus count of how many out of how many total. And these relative, we would call those percentages too. We could turn them into fractions or proportions or percentages. And then we talked about the difference between qualitative and quantitative. And I wanted you to see that all along in this section, they really were talking about qualitative data. So what level of education you have, that is a quality. Your blood type, that's a quality. Okay. What portion of your time is on class, homework, work, other. Those are all qualities. Okay, so this really had a lot to do with qualitative data in this particular section. And we were reading and we were creating bar graphs and pie charts all along the way. So this section actually had quite a bit of information in it. And but when it came down to it, we were taking some raw data or taking a representation of data. If we started with raw data, maybe we could represent it in a way that was more useful and easier to interpret. If we had a representation of the data, was it a good representation? What did it give us? Like, what's the difference between using a pie chart and a bar graph? Is there a difference? What's the difference here with these stacked bar graphs? So we really just use different representations in order to get an idea across to the reader. And I think that's the point, is to tell the reader, here's what we know, and from that, we're going to make a better decision based on information we've gathered or researched. Okay? So, in the end, it's all about making good decisions.